Students, this is Srinivas. We are discussing the problems on RH criteria. See, this is the problem. This is the open loop gain G of S is equal to K by S plus 2, S plus 4, S square plus 6S plus 25. Here the unity feedback H of S. By using this system, we find the stability of the system. Okay na? In order to find the stability of the system, we are consider some following conditions. Conditions based on that condition, the given system stable or not we define. Here, in order to find that stability, first this open loop system is converted into closed loop transfer function. Here the C of S by R of S is equal to, here the G of S by 1 plus G of S into H of S. Here this is the closed loop transfer function. Here the closed loop transfer function. Here the G of S is nothing but K by S plus 2, S plus 4. Here the S square 6S plus 25 by here the 1 plus K by S plus 2, S plus 4 and S square plus 6S plus 25. By simplifying this equation, here the finalized transfer function, here the C of S by R of S is equal to K by, here the S plus 2, S plus 4 and S square plus 6S plus 25 plus K. This is the finalized transfer function. Okay na? For this transfer function, this is called characteristic equation, denominator. The denominator of this transfer function is called characteristic equation. Based on this characteristic equation, here the given system stable or not we define. Here, in order to define the stability or not, here first condition is here the all the poles are located on left side of the S plane. First point is the poles must and should located on left side of the S plane. Here the next one is no missing terms are present in a characteristic equation. First one is the poles. By considering the poles, second one is the missing terms. Okay na? Missing terms. Here what is the mean by missing terms? We will see now. Here the next one is the sign changes. Next one is the sign changes. That means here this equation, for this characteristic equation multiply these values, we will get here the fourth order equation S power 4, here the 12S cube plus 69 S square plus 198S plus 200 plus K is equal to 0. In this equation, first one is the poles located on left side of this plane. These are the poles. Here how many poles are there? 4 poles. This is the second order equation. Here in the second order equation we have the 2 poles. These 2 poles. Total pole number of poles are 4. These poles, 4 poles are located on left side of the S plane. This is the axis, real axis, imaginary axis. Here these poles are located on left side of the S plane. Next one is the missing terms. Missing terms means this is the fourth order equation. Here 4, 3, 2, 1 and S0. That means there is no missing terms are present in this characteristic equation. Okay. Next one is the sign changes. Sign changes is nothing but here the coefficients of this characteristic equation, it consists of same sign. Here the positive, 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 positive. Okay na? There is no sign changes in this equation. Here based on this equation, the given system is said to be stable. Okay na? By using RH criteria, here we define what type of stable system. Marginally stable or absolutely stable or limitedly stable. And also we find the value of K. Okay na? By using RH criteria. See here the equation, here S power 4 12S cube plus 69S square plus 198S plus 200 plus K is equal to 0. By using that equation, here the S power 4 S cube S square S power 1 S power 0. Here the S power 4 is nothing but even. Here the 1 69 200 plus K. Next S cube is odd. Here the 12 198. This is the 0. Here for the simplicity purpose, this S cube is the 12 198. Okay na? In this equation, for the simplicity purpose, here the divide this equation by 12. Here I will get this is divided with the 12. I will get 1. This is 16.5. 16.5. Here in order to get the s square s power 1 s naught, here the multiply 1 into 69 minus 1 into 165. Here the 1 into 69 minus 1 into 16.5 by 1, we will get here the 52.5. This is the value is the 52.5. Next here 1 into 20 plus k minus 1 into 0 by 1 is nothing but 20 plus k. 20 plus k. Here this is the value 1 into 20 plus k minus 1 into 0 by 1, that is equal 20 plus k. Okay. Next one is the here the 52.5 into 16.5. Here 52.5 into 16.5 minus 1 into 200 plus k by 1. Okay na? By simplify this equation, we will get this is a 52.5. Here we will get 666.25 minus k by 52.5. This value is 666.25 minus k by here the 52.5. Okay na? Next these are the multiplication. Again here the this multiplied with the 0, 1 multiplied with this, no value is nothing but 0, that is the 0. Okay na? Next is s power 0. S power 0 is nothing but this total value is multiplied with the 200 plus k minus here the 52.5 by into 0 divided by this value, and these two values are cancelled. Finalized value we will get here the 20 plus k. 20 plus k. Here by using this equation, by using this columns, okay na, we find the value of k. Here in order to find the value of k, here the first we consider here the 666.25 minus k by 52.5 is greater than equal to 0. Okay na? Here the 666.25 minus k is greater than equal to 0. Here the value of k is 0 less than k less than here the 666.25. This is the one value. The value of k is the 0 to 666.25. Next another one is the here the 20 plus 200 plus k is greater than equal to 0. Here the value is the 0 less than k less than 200. These are the two values. The range of the k is the one is the 0 to 666.2, another one is 0 to 200. Okay na? This is the value of k. Okay. Next we find the in this problem also we find the damping oscillation. Okay na? Oscillation. Here oscillation frequency. Here in order to find the oscillating frequency, here we consider the this given auxiliary equation. Based on this auxiliary equation, here see here in this auxiliary equation is the 52.5 square, okay na, plus here the 200 plus k is equal to 0. Okay, by using this equation, here the 52.5 square plus here the 200, here the value of k is the 666.25 is equal to 0. This value is shifted to that side. Okay na? Here we will get here the 52.5 s square is equal to minus here the 866.25. Here the s square is equal to minus 86625 by here the 52.5. 52.5. Here we will get here the s square is equal to 16 minus 16.5. Here we need only omega. Here the s is equal to j omega. Here the substitute here j square is nothing but here the j into omega square is equal to here the minus 16.5, minus 16.5. Here j square is nothing but minus 1. Here the omega square is equal to 16.5. Here the omega is equal to root 16.5, that is equal to 4.06. The value of omega is here the 4.06. Okay, next one is we know we find the omega values and k value. Okay, now this is the problem is by using RH criteria. Okay, so now we will see another problem. Here the another problem is by using RH criteria. Here the next problem is u of s is equal k into e power minus s by s into s square plus 5s plus 9. Here in this problem, here the open loop gain, here the h of s is equal to 1, that is the unity feedback. Here again we find the transfer function. Here the c of s by r of s is equal to here the g of s by 1 plus g of s into h of s. Okay, now here see here k into e power minus s. Here the e power minus s can be rewritten as 1 minus s. Here the e power minus s is equal to 1 minus s. Here the by s into s square plus 5s plus 9 by here the 1 plus g of s is nothing but k into 1 minus s. Here the s into s square plus 5s plus 9 into 1. By simplifying this equation, here we will get here the finalized function. Here the c of s by r of s is equal to here the s into s square 5s plus 9 plus k into 1 minus s is equal to 0. Here the by multiplying this equation, here we will get here the s cube plus 5s square plus 9 minus k into s plus k is equal to 0. That is nothing but it is a third order equation. By using this equation, it is the same. By using stability condition, all the poles are located on left side of this plane. There is no missing terms are present. Here the coefficient is the same coefficients of the given characteristic equation. Here by using RH criteria, s cube, s square, s power 1, s power 0. Here the 1, 9 minus k. Next one is the 5. Here the k. Here the multiply this one. Here the 5 into 9 minus k. Here the 45 minus 5k minus k by here the 5. That is equal to here the 45 minus 5k minus k by 5. Here the 45 minus 6k by here the 5. Okay, na? Here this the value is here the 45 minus 6k by 5. Next one is this is the 0. Again this multiply this one. Here the divide with the 45 minus 6k by 5. Okay, na? Here we will get the value is the only k. That means in order to find the value of k, here in order to get the value of k, here the 45 minus 6k by 5k greater than equal to 0. Here the 45 is less than 6k, that is equal k is equal 45 by 6. 45 by 6. Okay, na? By simplifying this equation, here we will get here by simplifying this one, here the simplifying this one, we will get the k value is here the k is equal to here the 6 7 42. Okay, na? 3 here the 7.5. The value of k is the 7.5. Okay, na? This is the way of calculation of by using RH criteria. Here the value of k is 7.5. Okay, these are the problems on RH criteria and stability. Okay, thank you.